It's the biggest passenger jet Boeing has ever built, the most advanced wing in aviation. Over 600 orders on the books, Emirates alone wants 270 of them. But look at the list. Every major airline lining up for the 777X, and then the three biggest airlines in America. American has 0 orders. Delta has 0 orders. United has 0 orders. The country that builds this plane will not buy a single one. And once you understand why, you will see the 777X is not Boeing's comeback. It is the slowest motion crisis in modern aviation. It is 7 years late, $15 billion underwater, and the home team has already walked away. Boeing designed the 777X step into the space left by the giant 4-engine queens of the past. It was built as the company's next premium flagship widebody, a machine engineered to carry the heavy-lift legacy of the legendary 747 into a twin-engine era. This is the largest twin-engine passenger jet in history. Unlike the double-decker giants of European design, 777X is a single-deck aircraft relying on aerodynamic efficiency rather than a multi-level cabin. To lift this massive fuselage, engineers developed a carbon composite wing so wide that it surpassed normal airport gate limits. To solve this, Boeing introduced folding wingtips that retract on the taxiway, shrinking the 335-foot wingspan down to fit existing airport gates. Powering the jet are 2 GE9X engines, the largest and most powerful commercial turbofans ever built, with a fan diameter roughly equal to the fuselage of a Boeing 737. This engine and wing combination promised a 10% reduction in fuel burn compared to the older 777-300ER. On paper, it offered the high-capacity lift of a jumbo jet, with the operating costs of a twin-engine plane, presenting the ultimate commercial logic for international hub-to-hub routes. Boeing officially launched the 777X program in November 2013, promising that the first airline would fly the massive wide-body by 2020. That deadline came and went. Instead of welcoming passengers, the aircraft entered a multi-year delay spiral that has pushed first deliveries out to 2027. This 7-year slip transformed a highly anticipated flagship into an ongoing industrial challenge. The trouble began structurally. On September 5, 2019, during a high-pressure static test, a prototype fuselage split open just behind the wing. The explosive depressurization blew a passenger door outward at 148% of its design load. While Boeing treated this as a minor structural setback requiring a simple door frame reinforcement, the dramatic failure immediately drew intense regulatory attention and delayed the test schedule. Then came the engines. The massive GE9X turbofans ran into durability issues under high cycle conditions, with turbine blades wearing out faster than anticipated. A quiet disagreement arose between Boeing and General Electric over acceptable blade life thresholds, forcing more bench testing and design revisions. But the biggest hurdle was regulatory. In the wake of the 737 MAX crisis, the Federal Aviation Administration overhauled its certification process. The FAA subjected the 707X to unprecedented scrutiny, demanding complete physical test data packages for high-stress components and requiring new flight deck alerting systems. Each safety review, structural adjustment, and engine modification added weeks, then months, and finally years to the timeline. A program built to lead the global market became stuck in a cycle of constant correction, leaving foreign buyers waiting for a jet that remains, for now, a promise of the future. This waiting game has translated into massive balance sheet damage. Boeing has accumulated between $15 and $16 billion in total program charges for the 777X, driven by the mounting costs of these delays. The most severe single blow hit in the third quarter of 2025, when the company recorded a $4.9 billion pre-tax charge that devastated its quarterly earnings. But the financial pain is not just on paper, it is physically visible on the tarmac at Payne Field in Everett, Washington. There, roughly 30 complete 777X jets sit parked in storage. Because Boeing kept building these airframes while certification requirements continued to shift, these brand new planes were completed to earlier design standards. They now require a years-long process of structural modifications and systems updates before they can ever be delivered. Meanwhile, customers are forced to adapt. Lufthansa, designated as the launch customer, is still waiting for its first delivery. Faced with a schedule that has slipped years past the original target, the airline has had to implement a backup plan, extending the life of its current fleet and relying on Airbus A350s and Boeing 787s to fill the gap. The flagship project has transformed from an engineering dream into an active drag on Boeing's balance sheet. American Airlines, Delta Airlines, and United Airlines operate some of the largest passenger fleets on Earth, including hundreds of older Boeing 777s. Yet, in the order book for Boeing's brand new flagship, their combined total stands at 0. Not a single major United States carrier has placed a firm order for the 777X. This total absence of domestic interest exposes a fundamental shift in how American carriers build their networks. Instead of maximum capacity, United States legacy airlines have prioritized frequency, flexibility, and point-to-point growth. They have pivoted towards slightly smaller, highly efficient twins like the Boeing 787 family and the Airbus A350-1000. These aircraft allow airlines to schedule multiple daily departures between city pairs, capturing premium business travelers who demand schedule options rather than relying on one massive daily flight to fill a giant cabin. To carriers like United, the 777-9 is simply too much airplane. United's network planners explicitly determined that a 426-seat jet does not fit their multi-hub model, which relies on nimbler widebodies capable of opening niche international routes. Beyond route economics, Boeing's open-ended delay cycle created an unacceptable planning risk. With first deliveries slipping 7 years past the original target, United States carriers could not freeze their fleet renewal plans. They chose to renegotiate existing leases, extend the service lives of older planes, or buy Airbus instead of betting their future on a shifting certification timeline. This domestic rejection stands in stark contrast to the Middle East. Emirates has committed to 270 of the aircraft, anchoring its entire business model on the high-capacity hub-and-spoke system of Dubai. While Dubai funnels millions of connecting passengers through a single global superhub, United States Airlines spread their operations across multiple domestic hubs. Boeing designed and built the world's largest twin-engine passenger jet in Washington state, but its home market has completely walked away. The commercial trajectory of the 777X echoes the Airbus A380, not in physical design, but in pure market logic. While the A380 was a massive double-decker and the 777X is a single-deck twin, both were built to solve the same problem, moving massive volumes of people between giant hubs. But global aviation has fundamentally shifted. The era that rewarded super jumbos has yielded to a point-to-point model. Airlines now prioritize frequency and flexibility over raw capacity. Spreading passengers across multiple smaller flights reduces the risk of overcapacity, the exact threat that ended the A380 program. For the 777X, the economic test is identical. At this extreme scale, even a single-deck, twin-engine jet becomes a hub-dependent giant. By walking away, American Airlines rejected this high-risk capacity game. They chose the agility of smaller widebodies, leaving this homegrown giant to face an industry that has largely outgrown the economic model it was built to serve. Today, America's greatest aerospace triumph flies without American passengers. The 777X's true legacy isn't its engineering, but its geography. Is this giant twin-engine jet a commercial failure, or did the US market simply opt out of the world it was built to serve? Share your thoughts below.